Alright, here we have some examples to kind of illustrate some of these probabilities. If we draw two cards at random from a deck, what is the probability that only the first card is red? Drawing two cards from a deck, I guess I'm going to be making the assumption, I probably should have written it in here, that this is without replacement. It's not like we're drawing a card, putting it back, then shuffling and drawing another card. When you just say you're drawing two cards, it's assumed that this is without replacement. So that's kind of what I'm going for here. What is the probability that only the first card is red? So in order to do this problem, I need to kind of define some events. Of course, very creatively, I'm going to call them E and F. E is the event the first card is red. F is the event the second card is red. Now you may be saying, why didn't I define F to be the second card being a black card? I could have done that just as easily, but I'd like, when I'm defining events, for them to be kind of formed a similar way. Both of these are the event the card is red. When I'm trying to write this down, if I find the probability that only the first card is red, I can write this using those two events. So the first card is red, but the second card is not red. In other words, E intersect F complement. Now I used an intersection here because I said both of these things need to be true. The first card needs to be red, but not only that, the second card has to not be red. That's the F complement that I'm using here. So I'm trying to find what is the probability of E intersect F complement. Alright, if I'm going to use my product rule, let me write down what my product rule says from the previous page. Alright, so there's my product rule. The probability of the intersection of those two events is equal to the probability of the second event, I choose to think of it as the second event, F, times the probability of the first event times the probability of the second event given the first event. It's just easier to think of it when you're doing conditional probabilities. You think of telling a story, and so it's easier to tell the story kind of in chronological order. It doesn't have to be, but that's easier for me to think about, at least. So in this particular instance, I'm thinking about, okay, what event happens first? Well, I draw the first card first, so I'm going to say the probability of E. This one is phrased so that it starts off with the probability of F. There's also no complement in here, but these are just placeholders. When I say E and F, they're just placeholders. I can swap things around. I can move them around however I'd like. I could, for instance, think of this as, I could put an F complement on here by putting an by making that an F complement and that an F complement. That's not exactly what I'm looking for here, though, because F in this example, or in this instance, kind of looked like F was the first event, but in my example, I'm making F the second event. So let me think of it this way: E intersect F. We could have actually started off by saying E was the first event, and we're talking about the probability of F given E. So I'm just renaming what my events are here. If it helps it if it makes it a little bit more clear, you could actually think of this as being F intersect E. But intersection, the intersection is it's a commutative operation, so it doesn't really do anything. In any case, if I put the F complement in here, you can see this is exactly what this is the thing I'm talking about up here, and it put the F complement over there. So we get the probability of E times the probability of F complement given E. So you could go about this whole approach trying to modify that, but the easier things to think of is this is your first event, and this is the second given the first. So here, I have E and F complement. The first thing to happen is that I draw a red card. The second thing to happen is the probability of drawing a non-red card given that I drew a red card. So in any case, the probability I drew a red card is, you could write it as 1/2 or 26 out of 52, however you'd like that. I don't have to worry about anything else, any weird business going on there, so that's just 26 out of 52. When I do the probability of F complement given E, then I'm saying, well, I've already drawn a red card on my first try. What's the probability that the second card is not a red card? Well, there's 26 non-red cards left, 26 black cards left in the deck, but there's only 51 cards left in the deck total. So we end up getting 26 out of 52 times 26 out of 51. I could actually multiply those together, but it's not terribly meaningful, so I'm actually, at this point, I kind of stopped multiplying them together as part of the examples. In any case, what is the probability that both of them are red? Fortunately, I've already defined these events in such a way that these questions, these kind of follow-up questions, are pretty easy. The probability that both of them are red, this is the probability of E intersect F, and, well, the first event is E times the probability of the second event given the first event. So we're saying we get 26 out of 52. The probability of the first card is red. The probability of the second card is red, given that the first one is red, would be 25 out of 51. That's actually what we did in a previous video. And that would give us, this multiplication would give us the probability that both of them are red. Maybe I should actually multiply these together, because I think I'm going to be using those numbers in a little bit. Let me think of this. Instead of 26 out of 52, I actually am going to think of it as 1/2. In this way, I can kind of do some reducing here. The 2 in the denominator cancels with the 2 up here. We end up with 13 out of 51. This one, when I get 1/2, actually, that's not. I don't think I want to do that cancellation. What I'm noticing here is I'm probably going to want to keep these things with the same denominator, so I'm actually going to call this 26 out of 102. This one right here is going to be 1/2 times 25 out of 51. This is 25 out of 102. You can see these probabilities are almost equal, but of course the probability of getting both of them being red is a little bit less than the probability that only the first card is red. So let's see. If I wanted to figure out the probability that at least one is red, one way to think about this is, well, either the both of them are red, only the first one is red, or only the second one is red. So E intersect F, both of them are red. E intersect F complement, only the first one is red. E is red, but F is not red. This one right here says E is not red, or the first one is not red, and the second one is red. So these are the three sort of instances where we get at least one of the cards being red. This one right here, we already figured out this probability. That's 25 out of 102. This one right here was 26 out of 102. That's what we figured out up there. And this one actually you can get through symmetry, or just you could run a problem very similar to what we did up above. It's also going to be 26 out of 102. And now you can see the reason why I kept these with the same denominator. It's so I could add these numbers together. I was kind of seeing what was coming. If I add all three of these numbers together, I end up getting, what is that, 77 out of 102. Or, alternatively, we could do 1 minus the complement. So the complement here, the complementary event, I'm saying what's the probability that at least one of these cards was red. The complement would be the event that both of them were not red. Both of them are black. So 1 minus the probability of E complement intersect F complement. The probability of both of them being black, through symmetry, we can see that that's going to be the same as the probability that they're both red. So this would be 1 minus 25 out of 102. And when we're using the complement rule, the really handy trick is to convert that 1 into the denominator divided by itself. So 102 divided by 102 minus 25 divided by 102. And this is another way to get that 77 out of 102 that I got. If we wanted to construct a tree diagram to show all these different possibilities, I would start off by saying E. Well, you know, we're talking about when we draw the first card, it's either red or not red. So when we go up, the first card is a red card. If we were to go down, the first card is a black card. Now, once we go up, we talk about drawing the second card. We can either get a red card for the second card or a black card for the second card. So this would up here would be E intersect F. Then this one was E intersect F complement. So a red and a red and a black. This one would be F and F complement. This one is E complement intersect F, so a black card then a red card. And this one is E complement intersect F complement. You're getting 2 black cards. You can actually figure out the probabilities of each of these, or we actually already figured out the probabilities of each of these. You could fill them in. We could say the probability up here is 25 out of 102. Probability here is 26 out of 102. This one is 26 out of 102, and this one was 25 out of 102. So these are all sorts of, a couple of different ways of looking at this particular, these 2 events happening. It's a really simple thing, just drawing 2 cards out of a deck, but there's a bunch of things that could happen. You could get a red then a black, black then a red, black, black. They all have their own different probabilities, and you could go further. You could talk about the Venn diagram here as well. I'm not going to do that on this example though.